All right, we're going to look at derivatives of trig functions today. On the screen here is the graph of sine function. We've looked at this one in trig. Sine of 0 is 0, so you see a point right there. If you go sine of pi over 2, the value of that becomes 1 here. At pi, it's back to 0. At 3 pi over 2, the value becomes -1. And then 2 pi, it's back at 0. And then we've made one full cycle of this graph, and it just repeats. Well, what if we wanted to find the derivative of the sine graph? Remember, derivatives are finding what is the rate of change or slope. So let's estimate what the slope is at some of these points. At pi over 2 and 3 pi over 2, that should be pretty easy. At pi over 2, this slope is 0. At 3 pi over 2, the slope is also 0 because its tangent line would be horizontal. At 0 here, this is about a 45-degree line, so that slope we could estimate to be, looks like pretty close to 1, up 1 over 1. At pi, we got the exact opposite, slanting down the other way, so that slope appears to be -1. And then back at 2 pi here, looks again to be back at +1. So if we were to graph those points and then kind of connect them as best as possible, the graph would look like this. So just kind of explaining this again, here's a slope of 1, so we'd put a point at 1. Here's a slope of 0, so we'd put a point at 0 on the derivative graph. Slope of -1, so we'd put a point at -1. Slope of 0, put a point at 0, and so on. And if we connect these, we get a graph that would look like this. Well, what is this a graph of? Well, if you remember back from trig, this is the graph of cosine of x. So what that tells us is if you take the derivative of sine, you get the cosine graph. So derivative of sine ends up being cosine. If you were to do this again and now find derivative of cosine, it doesn't actually go back to sine. It's going to look a little bit different. So if we were to do this again and kind of graph it again, slope here would be 0. So slope of right here would be 0. Slope here would be -1. So here would be -1. Slope here is 0. Slope here is +1. Slope here is 0, so we get this graph. This is not the graph of sine anymore. It's actually a reflection of the sine graph over the x-axis. So what we get is that derivative of cosine is the reflection of sine, so it'd be sine with a negative in front. So derivative of cosine gives you negative sine. And so those are two derivatives that you are going to need to know. They're pretty important ones here. Derivative of cosine is cosine. Derivative of cosine is negative sine. From these, we can figure out derivatives of our other trig functions, such as tangent, cotangent, cosecant, and secant. And you can see them listed up here, what they end up being. How you find these out is to use our trig identities that you did back with these, and these are ones you also should know here. So like if you were trying to find tangent, what the derivative of that is, you're going to want to know what tangent's equal to. Well, tangent's the same as sine over cosine. So you would think of it as sine over cosine. We know those two, so we should be able to do quotient rule and find that derivative. If you wanted to do cotangent, that's cosine over sine, the reciprocal. The other two we got here, cosecant, remember that's the same as 1 over sine. And then secant is the reciprocal of cosine, so that's 1 over cosine. So what you'd have to do is find these derivatives by using quotient rule and knowing the derivatives of sine and cosine. So these two you do need to know You can find all the other ones off those ones, but those ones you do need to know. Okay. The other ones you could find if you needed to with quotient rule. Or as you keep doing these, you should start memorizing a few of them, I'm sure. All right, some other trig identities you should keep in mind that could pop up when doing some of these, or maybe you need them to simplify some of these trig derivatives. One is, what is sine squared plus cosine squared equal to? When you're doing trig stuff, that's that Pythagorean identity from unit circle, that equals 1. So that kind of fills in the joke over there. Also off of this, if you were to divide by cosine squared or sine squared, you can get some other ones off of this. For example, if you were to go through and divide everything by cosine squared here, you would get a identity kind of off of this one. So sine squared divided by cosine squared, that sine over cosine is the same as tangent, so you get tangent squared. Cosine squared divided by cosine squared, that'd be 1. 1 over cosine is the same as secant, so that would equal secant squared. And so that's kind of a play off of that Pythagorean identity. Those two things would also be always equal, and that's how you kind of fill in the joke over here. All right, so just kind of keep those identities. Those are ones you should, or at least this one you should know right here and be able to find the other ones off of that. Let's try one where they want you to prove it here. So they say, prove that the derivative of cotangent is in fact negative cosecant squared. That's one of those we had just a little bit ago. That was up on the screen here. They want us to prove this one. So let's show it with our quotient rule here. So what we're going to do is, instead of finding derivative of cotangent, we're going to find what's the derivative of cosine over sine, because that's what cotangent's equal to. So let's apply quotient rule to that. Quotient rule is low, so sine x, d high, derivative of the high derivative cosine we had was negative sine, minus high, it's down a little bit, high, so that would be our cosine, d low, derivative of the low derivative sine is cosine, all over low squared, so all over sine squared. All right, so now let's simplify this. Sine times sine is going to be sine squared, and it'd be negative because there's a negative on that one side. Minus cosine times cosine is cosine squared, all over sine squared here. Well, to simplify this here, this looks awful lot like that identity we just had, except it's negative. So let's factor out a negative out of that. So that would make this sine squared plus cosine squared. There's our good old Pythagorean identity. So now we know sine squared plus cosine squared, that's the same as 1. So if we change that to a 1, now this becomes negative 1 over sine squared, and 1 over sine is the same as cosecant, so that means this is the same as negative cosecant squared. And there we just showed what that derivative was up there. That derivative of cotangent is in fact negative cosecant squared. So that's where some of those derivatives come from, is using quotient rule, and you need to know those sine and cosine derivatives.